Okay, hi. Today we are going to discuss kertas peperiksaan percubaan SPM Negeri Selangor modul pintas 2024 Kimia paper 2. Okay, let's start. Okay, section A. Diagram 1 shows the classification of modern medicine. Okay, they give you modern medicine, streptomycin, which is W, psychotic drugs, X, aspirin. Question A, state the type of medicine W and X. Okay, so since W is streptomycin, so it is what we have as W is antimicrobial. Okay, X is, since it's aspirin, another example is like paracetamol. So these are analgesic medicine. Okay, that's 2 marks you have to write down. Just write down separately. Okay, don't write down antimicrobial, analgesic. You have to say which is which. W is what, X is what. Okay, next, what is the function of medicine W? Since W here, it is antimicrobial. Okay, the function is to kill or retard bacterial growth. Okay, or you can say to kill or retard the growth of bacteria. Okay, next C, give one example of psychotic drug. Okay, psychotic drug, the easiest for you to remember is haloperidol. Haloperidol is used for people who have hallucination. So the name hallucination and haloperidol, they are the same. Okay, you can give other answers also, example like chlorpromazine or clozapine. Okay, but I'm afraid sometimes the wrong when you wrongly spell it, then you will lose a mark here. Okay, so choose the one which is easy to spell it out. Okay, next, D, what is the function of medicine X? So medicine X here is analgesic. Analgesic, very easy. We eat aspirin, we eat paracetamol for what? It is to relieve pain. Okay, so sometimes you can see at conscious state you can write, but the moment you write relieve pain, you already get your mark. Okay. Question 2. Diagram 2 shows periodic table of elements. The elements labeled are not the actual symbol of the elements. Okay. State another name for group 18. So what is group 18? Group 18, we call them as noble gases. Okay. Next, B. Based on periodic table of elements in diagram 2, state the element that exists as monoatomic gas at room temperature. Give a reason. Okay, so here you can see group 18, they are monoatomic gas, so you write down A. Okay, give a reason because atom A has achieved stable. Atom A has achieved stable duplet, not octet. These are the first element in group 18, so they achieve duplet electron arrangement. Okay, so this is only second mark. The third mark is atom A do not need to, you must mention these three: receive, donate, or share electrons. Okay, so these are the 3 marks that you need to get. This is 1 mark, has achieved stable duplet electron arrangement, another mark. They do not need to receive, share, or donate, another mark. You can get a total of 3 marks here. Okay, next, 2. Element X is a transition element. Mark its position in the periodic table with an X. Okay, so periodic table is between here and here, so you can mark anywhere around here lah. Okay, that's the answer for 2. Okay. Question 3. Table 1 shows the information on atoms P, Q, R, and S. Okay. A. State one subatomic particle present in the nucleus of an atom. You can write proton, or you can write neutron, but you cannot write electron because electron is not in the nucleus. If they say one subatomic particle in an atom, then you can write either one of them. But in nucleus, you only have these 2. Okay. Question B. Which atoms are isotope? Okay, look at the given atoms. You see here who has the same proton number. Because what are isotopes? Isotopes are atoms of the same element that has the same number of proton but different number of neutrons or number of nuclei. So write down atom P and Q. Okay, they never ask the reason why, so no need. Okay, C, state the number of valence electron of atom S. Look at S. S has 20 proton. So if it has proton equivalent to question D. Draw the electron arrangement of ion R. Let's look at R. Where is R? R has proton 17. As I mentioned just now, 17 proton equivalent to 17 electron. So they have 17. But bear in mind, this is ion R. Okay, so if it's 17287, okay, so in order to be an ion, they need to receive one electron. It is easier to receive one originally it has 7, okay, but you add 1 here, okay, so don't forget to put a bracket here, and because you receive electron you are negatively charged, and you can write here are negative, okay, that is 2 marks. Question D2. Natural abundance is the percentage of isotope exists in a sample of element naturally. Calculate the relative atomic mass of R in 35R and 37R. Okay, so to calculate this, very easy. You can do RMM is equals to 75.8 times 35 plus 24.2 times 37 divided by 100. And you will have, your answer is 35.48. Okay. Question 4. Diagram 3 shows an electron arrangement of compound formed from the reaction between substance X and Y. Okay, they give you substance X and Y. Then they give you question 1A. Write down the electron arrangement of atom X. So because they ask us on atom X, so you see the charge here is +2. That means it has donated 2 electron, which originally it has another shell with 2 electrons. So the electron arrangement would be 2, 8, 2. Okay. Next, question A2. State the type of forces of attraction between the particles. Since this is positively charged and negatively charged, this is between metal and non-metal. So they form what type of bond? They will form ionic bond. Okay, when they form ionic bond, what are the attraction force? It should be electrostatic attraction force. Okay, if it's covalent compound, it should be a weak van der Waals forces. Okay, next is write the chemical equation for the formation of the compound. So X is metal, we write it as X plus Y. So since Y actually, if we look at the electron arrangement, they are actually receiving 2 electrons. That means they are 2, 6. Okay, 2, 6, you can check in the periodic table, they are oxygen. So you must write C Y2. Okay, then you get X, Y. Okay, you can also write magnesium plus O2, you get MgO. Okay, then you can balance it here, put a 2 here, put a 2 here. That's how you get your. But in soluble in organic solvent. Okay, or you can also write they are able to conduct electricity in molten and aqueous form. Okay, no problem. Okay, or you can also have high melting and boiling point. Okay, also can be accepted. Next, question B. Calculate the mass of the compound produced when 0.1 mole of X react with excess Y. Okay, so they're asking the mass of the compound. Let me just copy mole of X, you get 2 mole of XY, right? Now the question given you here 0.1 mole of X. So here 0.1 mole of XY as well. All right. Then you find the mass of Y. XY should be 0.1 times with the molar mass of the XY, which is 24 plus 16. Okay, so your answer would be 4 gram. Okay, so if you look at the question, it is 2 marks. So 1 mark here and 1 mark here, 2 marks. Okay. Question 5. Diagram 4 shows a type of ceramic that is used to make tandoori furnace. Based on diagram 4, state the main material in ceramic. Okay, very easy. Ceramic, the moment you see ceramic, you know ceramic is made of clay. You can also say kaolin. Okay, or you can also answer aluminium oxide. Okay, all right, next. State one property of ceramic. Hard and strong. This is the easiest. You know, ceramic are hard and strong. You can also say chemically inert. You can also say high thermal resistance. You can also say heat insulated. Okay, all right. Next, question 3. State another type of ceramic. There are 2 types of ceramic. One is traditional ceramic. Another one is advanced ceramic. Okay, and advanced ceramic is made of the use we have a lot. Okay, so question 4, state one use of ceramic. You can use as cutting disc, you can say brake disc in the car, right? Cutting disc also can. Okay, question B. Diagram 5 shows the design of a car made from a type of composite material, which is carbon fiber reinforced polymer, where the matrix substance is polymer resin and substance Z as carbon fiber. Identify substance Z. Substance Z is actually a strengthening substance. Okay, strengthening substance. Okay, they want to know what is it. Okay, table 2 shows 3 types of composite material and their components. Okay, you have P, concrete and steel. Photochromic glass, you have glass, copper 1 chloride, and Q. R is yttrium carbonate, barium carbonate, and copper 2 carbonate, and oxygen. Okay, based on table 2, you need to identify what is P. When you see concrete and steel, they should be the reinforced concrete. Okay, reinforced concrete. Okay, when you see um, okay, when you see glass, copper 1 chloride, okay, so it has another one, photochromic glass. The important thing is you need to have silver chloride. So Q is silver chloride. Okay, then the moment you see yttrium here, they are actually part of superconductor. Okay, right. Question 6. Diagram 6 shows a type of bath bomb made from 2 materials, sodium bicarbonate and citric acid. Sodium citrate salt is produced along with carbon dioxide and gas and water. Now they give you a chemical equation, they ask you to balance it. Okay, so let's see here. Sodium here you have 3. So put the 3 here. Okay, directly. Next, you see carbon here has 6. Here has 6. Then you already put the 3 for the carbon here. So this one you need another 3 here. Okay. Next, left hydrogen and oxygen. Okay, the rest are done. The rest are done. Okay, so look at hydrogen oxygen. How many you have here? 3 times 3, 9. 9 plus 7, 16. Okay, next here you have oxygen has 7 here. 3 times 2, 6. So how to make this to be equivalent to 17? So it is balance. Okay, so this one you can leave it empty. You don't have to write anything. Okay, because it's already balanced. Next, state the qualitative information and quantitative information that can be obtained from the chemical equation. So from here, qualitative, you can talk who are the product and who are the reactant. Who are the product, 1 mark, who are the reactant, 1 mark. When you want to write quantitatively, 3 mole. How many moles are involved? How many moles? 3 moles of NaHCO3 react with 1 mole of this to produce 1 mole of that and that. Okay, so when you write that correctly, you will have this. Okay, show it to you. Okay, so sodium carbonate and citric acid. Okay, the reactants, just put as this. Okay, then what are the products? Write down the names. Okay, um, all right, settle. Question C. Myra used 2.52 gram of sodium bicarbonate to be reacted with citric acid to make bath bomb. Calculate the mass of citric acid that needed to be used. Okay, first step is you need to find the mole. Mole equals to 2.52 divide with the sodium bicarbonate. Okay, the molar mass, which is 23 plus, sorry, 23 plus 1 plus 12 plus 3 times 16. Okay, so use the calculator, you will get 0.03. Okay, next is you compare. Okay, we're comparing from the equation that we wrote just now. 3 mole of NaHCO3 okay, you are going to use only 1 mole of citric acid. C6H8O7. Okay, but for this case, you have counted 0.03 mole of NaHCO3. So how many mole of this? If 3 to 1, so 0.03 to 0.01 mole of C6H8O7. Okay, then finally you find the mass. So mass is equals to 0.01 times with, show the this one, 6 times 12 plus 8 times 1, the RMM, yeah, plus 7 times 16, okay, which is equivalent to 192. So 192 times 0.01, you get 1.92 gram. Okay, so show all this, you get 4 marks. Usually they'll give 3 marks, but sometimes if you see extra mark is given for this and this. Okay, so make sure you show them this calculation. Okay. Question 7. Table 3 shows 2 sets of experiments which are carried out to study the effect of other metals on rusting of iron. Okay, so you see set 1 here. They've given what is set 1. Okay, potassium hexacyanoferrate with agar solution. Okay, you can see dark blue spots here, and the low intensity of pink color is formed. Okay, then 2 is where you see no dark blue spot found here, and the intensity of the pink color is formed. So they give you this is metal P and this is metal Q. Okay, so now let's look at the question. What is meant by metal corrosion? Okay, metal corrosion is you need to write down you have to mention that it is a redox reaction where the metals are spontaneously oxidized when metal atoms release electron to form metal ions. Okay, they are redox reaction. You must have the word redox reaction. You must have the word spontaneously. Okay, spontaneously oxidized. We have to choose which one that will make the rusting faster. Okay, how do we know? Because you see there's a dark blue spots here. Dark blue shows indicates that the iron rusted. Or fasten the rusting of these metals that are lower than they are less electropositive than iron. Example, copper. Okay, you can give copper, you can give a lead, you can give tin. Okay, so I choose copper. So you write down copper. They say name, yeah, so you write copper. Okay, where else? Q should be the sacrificial metal that are more electropositive. So Fe becomes Fe 2 plus plus 2 electron. Okay, this is what happened. Now in right, if it's metal Q, we can write Q becomes Q2 plus plus 2 electron can. Okay, now oxidation here. It by adding 4 electron here, 4 here, and now 2 of water. Okay, and the same goes to set 2 as well. 2H2O is the same thing. Okay, here the reduction. Okay, so in this set 2, the iron is safe. It does not undergo oxidation. Now, based on table 3, which one is rusted? So you can say which set 1 lah. Okay. Question B. Diagram 7 shows a wired fence made of iron. Suggest one way to slow down the rusting process on the wired fence. Explain your answer. Okay, so now this fence, what can you do? Okay, you can slow down to slow down the rusting. Usually, what people will do, they will coat it with plastic or oil or paint it. Okay, so you can coat with plastic. Okay, or you can put it oil or you can paint it. Okay, you need to explain the reason to prevent exposure of iron, to prevent exposure of iron towards air and water. Okay, so it will last for a long time. Don't say change it to stainless steel because you already have the fence. You need to repair it. How can you do? Okay, so any logical answer will be accepted. Okay. Question 8. Diagram 8.1 shows the structural formula of two hydrocarbons that give you hydrocarbon A and hydrocarbon B. A. Name hydrocarbon B according to IUPAC nomenclature. Okay, so if you look at hydrocarbon B, they are alkene. Okay, how many carbon in the first place? You need to know. They are 2. to in. Okay, this is according to IUPAC. Okay. Question B1. State the meaning of isomer. What are isomers? Isomers are molecules that have the same molecular formula. Molecules that have same molecular formula but different structural formula. Okay, different structural formula. Okay, now B2, draw the structural formula for another isomer of hydrocarbon A. So hydrocarbon A, it has 4 carbons. Okay, so since they do not have double bond, so you can shorten the longest chain and you put a branch. Okay, and then you fill up all the hydrogens. Okay, so what is its name now? You don't need to write the name, but if they ask you what is the name, you can write down this is actually propane and 2-methyl. Okay, 2-methyl propane. Okay, they still have the same number of carbon and same number of hydrogen, but different structural formula. Okay, all right. C1. Hexane and hexene produce soot when burned. Compare the sootiness of the combustion of hexane and hexene. Okay, you can say hexene produce more soot. Okay, hexene produce more soot than hexane. Okay, you can see this when the experiment to check the sootiness of hexane and hexene. Okay, and you can also look at the question 2. Explain why there is a difference in the sootiness from the combustion of hexane and hexene. You can calculate the percentage of carbon by mass. Okay, let me show you how to calculate. You need to have the number of carbon atom. Example, in hexene, you have how many? You have 4. Okay, but the total number of molar mass here is different. So hexene here, 12 times 6, okay, and then you divide with 12 times 6 plus 1 plus 12. So you get hexene 85, hexane 83. So you can say hexene, the percentage of hexene is higher. Percentage of carbon by mass of hexene is higher than hexane. Okay. Question D. Diagram 8.2 shows a pair of shoes used by a badminton player. 1. Name this type of synthetic rubber. Okay, so you know that this is a synthetic rubber and they use SBR, styrene butadiene rubber. Okay, this is SBR rubber. Okay, right. Next question. Natural rubber and synthetic rubber can be used as materials for sport shoes. Choose the type of rubber that can be used as a material of the sport shoe sole and justify your answer, your choice. This is 2 marks. For the sole of the shoes, okay, you can either choose either one. Okay, if you want to choose natural rubber, you can write, okay, but you need to give a reason. Example, natural rubber is soft. Okay, they are comfortable to wear. Okay, compared to um, synthetic rubber. Okay, if you want to write synthetic rubber, you can say they are more elastic and you can wear longer. Okay, but if you want to write natural rubber, you can also say they have low heat resistance, so the sole can grip the flooring better. If synthetic rubber, you can say high heat resistance, the sole is not easily worn. Okay, so this is only 2 marks, what you choose and the reason. Okay, usually natural rubber are softer, so that's why they are chosen as the shoe sole. Okay. Section B, question 9. Okay. 9A, state the meaning of heat of displacement. Okay, heat of displacement here is the heat change. Okay, we can start with heat change. Okay, when 1 mole of metal is displaced from its salt solution by a more electropositive metal. Okay, so for example, the heat of displacement, when there is a salt example, we have copper sulfate, okay, and it is being displaced by a more electropositive metal, okay, to get MgSO4. So magnesium here displaced the copper from its salt solution. So copper is left alone here. Okay, so when starting on the question, usually if they ask what is heat of displacement, then we give a general statement here because 1 mole of metal is displaced from its salt solution. But let's say they give you an example of a reaction here and they want you to write down the meaning of heat of displacement. So you have to write heat of displacement is the heat change when 1 mole of copper is displaced from its salt solution, which is copper sulfate, by a more electropositive metal, which is magnesium. Okay. Question B. Diagram 9 shows the setup apparatus used in the experiment to determine the heat of displacement of copper by metal X. So we can see here it is given to us 1.0 mole 100 cm cube of copper sulfate solution. Okay, then we have a metal X powder, and then they check the thermometer with a check the temperature with a thermometer. Okay, so this is the beginning of the experiment, and this is the end of the experiment. Okay, and they give you a table here. Okay, now the table shows the results of the experiment. We can see the temperature of the solution before the reaction is 28 and the highest temperature achieved is 35.5. So you can see that the temperature here has increased. Okay, now let's look at question 1. State the color change of the solution here. Okay, when we look at the question here, solution given is copper sulfate. So copper sulfate is blue in color. Okay, so when copper is being replaced with another metal, you will get, originally it is blue, okay, then the color becomes paler, or you can say the intensity of the blue color decreases. So can be accepted. Color becomes paler. Blue color becomes paler. Okay, but mention the blue first, 1 mark, and what happens to the color is another mark. Okay. Next, name metal X. Write a balanced chemical equation for the reaction between metal X and copper 2 sulfate. Okay, like I said, you can choose a more electropositive metal. It can be magnesium, it can be aluminium, it can be zinc, iron, tin, or lead. Any one can be accepted. So you can write Mg plus CuSO4, and then you get MgSO4. Okay, it is already balanced. If you write zinc, you can write zinc zinc plus copper sulfate, you get zinc sulfate and copper. Okay, so make sure the reactant and the product is correct. So this one you don't need to do anything, you already get the second mark because it is already balanced. Okay, next, question C. Calculate the heat of displacement when 1 mole of copper is displaced by metal X. Okay, and they ask you to draw the energy level diagram. Okay, calculation is 4 mark, diagram is 3 marks. Okay, let's look at the calculation. Now, first step is you have to find the heat release. Heat release is Q is equals to MC theta. Okay, so 100 times 4.2 times 7.5. Where do we get the 7.5? From the here. 35.5 minus 28.5. Okay, so that is the theta. Okay, now your volume here is equals to the mass. So the mass here is 100 cm cube of the solution. So 100 cm cube becomes 100 gram. Okay, when you get this, you get 3150 joule. Okay, now hold that first. Next, we need to find the number of mole of copper sulfate. So MV over 1000. And the molarity is 1.0 times 100 divided by 1000. So you get 0.1 mole. So this is your second mark. Okay. Next is to find the heat of displacement, which delta H is equals to Q over N. So your first answer just now, divide with your second answer. So you get 31500 joule. Change it to kilojoule. So you get 31.5 kilojoule per mole, and make sure to put a negative here because you know that it is exothermic. How do you know? You look at the temperature change. Temperature increase, that means heat is released. Heat is released, it is exo. Okay, so this is your delta H. Okay. And next D is the energy level diagram. Okay, so you can write here if you want, you can write Mg plus CuSO4, you get MgSO4, and you write down your delta H here. Okay, must label the energy here, must label the reactant, must label the product, and must write down the delta H, and this arrow must go down because this is an exothermic reaction. Okay. E. Table 5 shows the name and the heat of combustion of ethanol, propanol, and pentanol. Okay, they're given us, and the fuel value for pentanol is not given. Okay, question. Based on table 5, calculate the value of Y, then choose a more suitable alcohol to be used as fuel. Justify your choice. This is 5 mark. Okay, and 2, if you are a nature lover, which alcohol will you choose as a fuel? Explain. Okay, now to find Y, okay, so find the fuel value for Y, you take 1380, okay, which is the, we want to see a fuel value for ethanol, okay, we are calculating one by one, okay, you see you get 30, okay, then propanol 2020, you divide with the molar mass, you get 33.7, okay, then fuel for alcohol is 332 divided by 88. Okay, actually this one you don't need to show because they only want for Y. Okay, and they've given you the molar mass, relative atomic mass here, so you can use this to find for pentanol. Okay, so pentanol is 88. Okay, so if you get confused how many carbon pentanol has, okay, one you can use the formula CnH2n plus 1 OH, okay, which is C5 H 2 times 10, 2 times 5 10 plus 1 11 and then OH, okay, or simply if you don't know how many hydrogen or you can't remember the general formula, what you do is you just draw 5 carbon. Pent is 5 because pentagon and pentanol is the same, okay, then it is alcohol, it must have 1 OH, okay, and then the rest you just need to fill up with hydrogen. Okay, so you have all. So you can find the total hydrogen by doing this. Okay, alcohol does not have a double bond. So all must be filled up with hydrogen. So 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct, 11 OH. Okay, then you calculate, your answer is 37.86. 37.86 kilojoule per gram. Okay, now we choose alcohol Y because why? Because the fuel value of Y is the highest. So that's why you choose Y. Okay, now if you are a nature lover, compared to all these three, why do you want to choose? How do you make choice? Okay, my suggestion would be you can choose ethanol. Why? Because you can say that less carbon dioxide is produced when every 1 mole of ethanol is burned. Obviously, because ethanol has less number of carbon compared to propanol or pentanol. Okay, so that's why we choose ethanol. Okay, less carbon dioxide is produced because we only have 2 carbon in ethanol, so it will produce less compared to pentanol. Propanol, they have 3 and 5. Okay. Question 10. Table 6 shows the information of 3 sets of experiment to investigate factors affecting the rate of reaction between excess zinc and 50 cm cube of 1.0 mole per dm cube hydrochloric acid. So let's see. Set 1, we have excess zinc 50 cm cube 1.0 hydrochloric acid. Temperature 40, time taken 56. Okay, so this is the thing. Okay, next is set 2, excess zinc 50 of 1.0, and you have some solution X. There's something special here. I'm going to highlight it with the green. You see solution X. This one, no solution X. And you see the rate of reaction is higher, okay? Because the time taken is shorter, okay? Then number 3, you see the difference is here, okay? The temperature is higher, making the rate of reaction is higher, okay? Next. Based on table 6, answer the following question. What is the meaning of rate of reaction? Okay, A1, the meaning of rate of reaction is the volume of hydrogen gas. Okay, volume of hydrogen gas released per unit time. Okay, sometimes you can see that the answer would be the release or the amount of product or amount of reactant. Do not write that, because based on this experiment, you know it is the volume of hydrogen gas. So the volume of hydrogen gas released per unit time. Okay. Question 2. Name the solution X and its function. Okay. Solution X in an experiment with a metal and an acid, the best catalyst would be, the only catalyst that you can think of is copper 2 sulfate. This is the one that is used. Remember, catalysts, their characteristics, they are very specific. They are only specific for certain reaction. You cannot use one catalyst for all the reaction. Okay, so what are the function? They are acting as catalysts. You can just say catalyst, or you can say increase the rate of reaction. Okay, if you want to say faster, can, but you say faster the reaction. You cannot say faster the rate. The rate has to be increase or decrease. Okay. Question 3. Write a chemical equation for the reaction between excess zinc and hydrochloric acid. Okay, so zinc plus HCl, ZnCl2 plus hydrogen gas. Okay, so put a 2 in front of HCl to balance it. Okay, and you get 2 marks here. Okay. Next, question B. Sketch the graph of volume of gas against time for set 1 and set 2. And then C, you have to calculate the average rate of reaction for set 1 and set 2. Let's look at the graph. Okay, now both will end up at the same line here because both are using the same concentration. Okay, so because of that, you know that set 2 is a higher rate because it is using catalyst. So you just make the graph to be a little bit steeper, okay, and it reaches rate of reaction here faster compared to set 1. It's a bit slower. Okay, you can see it's a bit not that steep, and it reaches here. Okay, so this shows that set 2 has a higher rate of reaction. Okay, so draw the x-axis. Make sure you label the x-axis volume of gas, and y-axis and the x-axis is time, and make sure you label set 1 and set 2. This one must, if not, you don't know which one is which. Okay. All right, next is to calculate the rate of reaction, the average rate of reaction for set 1. Okay, now you take 30 cm. Where do we get this 30 cm? Look back at the question. Okay, let me scroll back to the question. See here, time taken to collect 30 cm cube of hydrogen gas. So the total gas release is 30 cm cube. 30 cm cube divide with the time. Set 1, it take 56 seconds. Okay, so 0.54 cm cube as negative 1. Okay, you also can write 0.54 cm cube as negative 1. Okay, or you can put a slash. All right, set 2 is 30 divide with 42. Okay, because it's faster, right? So it's 0.71 cm as negative 1. Okay. All right, you can take up to 2 decimal point if it has longer, 4, 5, and so on. Okay. Next question D. Based on the information in table 6, compare the rate of reaction between set 1 and set 2 and set 1 and set 3. Okay, for this case now you have 10 marks here, so you have to divide 5 marks here, 5 marks here. This is based on collision theory. Okay, so you must have 5 points for each. Okay, let's look at first set 1 and set 2. Now, set 1 and set 2, you can see set 2 is higher than set 1, the rate of reaction. This is your 1 mark. Okay, next. Set 2, you mentioned that catalyst is being used. Okay, then what is the function? It lowers the activation energy by providing an alternative pathway. Okay, that's your number 3. Number 4 is you can mention about more reactant particles. Mention the zinc atom and hydrogen ion. Why hydrogen ion? Because this is from the acid HCl. They will ionize. Okay, so mention this. Okay, can achieve activation energy in set 2 than set 1. Then finally, frequency of effective collision between the particles is higher in set 1 and set 2. Every sentence you compare between set 1 and set 2. Set 1 and set 2. Okay, now let's look at the next one, set 1 and set 3. Set 1 and set 3, remember they are different in terms of temperature. So mention first the rate of reaction for set 3 is higher than set 1. Okay, then the temperature of acid is higher in set 2. Don't mention the temperature in set 2 is this, temperature in set 1 is this. No, we want it is higher. You must mention that set 3 has a higher temperature. Okay, the next Third mark would be talking about why. Temperature got to do with kinetic energy. Okay, kinetic energy for particles in set 3 is higher than set 1. Then you go into the frequency of collision. Don't forget to mention between hydrogen and ion and zinc atom. This is very important. If not, you will not get the fourth mark. Okay, you will not get this one. This is, you say it is bersyarat. Bersyarat means you need to, this frequency of collision, you can write here, or you can write here frequency of effective collision between hydrogen ion and zinc atom. You must at least mention them once, either one place. Okay, finally, frequency of collision. Once you mention above already, down here, you just mention particle is higher in set 3 and set 1. Sometimes students will ask, teacher, can we write this rate of reaction at the end? It doesn't matter. You can write in the bottom, or you want to write at the early sentence to show which rate is a higher one. It doesn't matter. As long as you have all this, you get your total 5 marks. Okay? Okay, section C, question 11. Diagram 10.1 shows the pH value of solution when a student dipped pH meter into 2 beakers containing acid of the same concentration. Okay, it's the same concentration. 0.1, 0.1 nitric acid, but this one is 0.1 ethanoic acid. Okay, and here is 1 and here is 5. Okay, let's look at the question. State the meaning of pH. A1. A2, based on diagram 10.1, explain why the pH value in solution in beaker A and B are different despite having the same concentration of acid. 4 marks here. Okay, let's look. The answer for what is pH, okay? This one, a lot of students are not able to remember, but I hope you please remember it is a logarithmic measure of the concentration of hydrogen ions in an aqueous solution. That's it. Okay, try to remember this. The one highlighted, the one underlined is a mass. Okay, concentration of hydrogen ion in an aqueous solution. Okay, now answering question A2, why the pH value is different. Okay, first you mentioned that nitric acid is a strong acid, right? So it ionizes completely in water. Okay, to produce a higher concentration of hydrogen ion. Okay, and you also mentioned that so ethanoic acid is a weak acid. You can add in this one is a strong acid and this is a weak acid, but that's not enough. You have to mention that they ionize in water partially to produce lower concentration of hydrogen ion. Okay, so you can see that beaker A contains higher concentration of hydrogen ion compared to beaker B. Why? Because it is a strong acid, right? All of it has been ionized. So you can see the higher the concentration of hydrogen ion, the lower the pH value. Okay, that's your 1, 2, 3, 4 marks. Question B. Diagram 10.2 shows two solutions. You see here, sulfuric acid 0.1 and sodium hydroxide 0.01. Now, all sulfuric acid is poured into the beaker, okay, containing sodium hydroxide solution. Using stoichiometric approach, determine which solution is in excess. Okay, now explain one way to verify the presence of excess solution stated in 11b1. Okay, now we want to know, first of all, let's try to find write down the equation first, chemical equation. H2SO4 plus NaOH, you get Na2SO4 and H2O. Okay, now next is you want to find the number of mole. Okay, for this, let's see here, number of mole for sulfuric acid. Mole is equals to mv over 1000. So 0.1 times 10 divided by 1000. So using your calculator, let's calculate 0.1 times 10 divided by 1000. Okay, 0.001. Okay, next is, let's find the mole for this. Mole here is mv over 1000. So 80 times 0.01 divided by 1000. So 80 times 8 Okay, right, now let's see. From equation, 1 mole of H2SO4, you also use 2 mole of NaOH. Okay, now for the sulfuric acid is 0.0 and 0.001 mole H2SO4. So 0.0008, 0.0008 mole. Okay, so when you look at this, you can see that this is double by double. 1 mole of acid, you must use 2 mole of this. If you use 0.001 mole of this, so how much is this? Okay, so this is actually, there's something wrong with the scheme here because 0.001. Okay, now which one do we choose is smaller? Okay, now when you have two solution, okay, now which value is smaller? This value is smaller, this value is bigger, right? You see there's 3 0 here, there's 1. So when this happen, you need to take this one. So this one is more than this. Okay, so this shows that sulfuric acid is in excess. Okay, sulfuric acid, you have more. Okay, then what is the question here? Okay, determine which solution is in excess. So you write down lah, sulfuric acid. Okay, now they're asking you one way to verify the presence of the excess solution. It's very simple. You can use litmus paper. Okay, so you can put a litmus paper and then you can see if it's alkali, you use blue turns to red. If you use acid, red turns to alkali, red turns blue. Okay, for acid, it is blue turns red. So for our case here, it is H2SO4, right? In excess, so when H2SO4 excess, we use blue litmus paper. Okay, so you mentioned insert the blue litmus paper, okay, into the mixture, and the blue litmus paper turns red to show that the mixture is acid. Okay, if let's say you have another question that you use and the excess is alkali, you use a red litmus paper. The red litmus paper you dip into the solution and it turns blue, showing that the solution is alkali, they are excess. Okay, so this one you have to be very careful. Okay, next C. Sulfuric acid can be used to produce copper 2 sulfate salt. By naming a substance needed to react with sulfuric acid, describe the steps to produce copper 2 sulfate salt in school laboratory. Okay, this is 7 marks. So from here, you just list down the substance that you want to use, which is copper 2 oxide and copper 2 carbonate. Okay, because you want to make copper salt. Okay, so from acid, so you can either use acid plus metal oxide, or you can use acid plus metal carbonate. Okay, whichever one. All right, so do not write copper because acid and metal cannot react because copper is less electropositive. Okay, so first step is you have to pour about 20 to 50. Remember, whenever you want to write procedure, use the concept of 3A. What is 3A? A is action, second A is amount, and the third is apparatus. Okay, so action, what is your action? Your action is pour amount into a beaker. Okay, then you heat it a bit. Okay, then you're going to add copper 2 oxide until there is undissolved powder. You're going to stir. Okay, next you filter out the excess copper oxide from the mixture, which one the one has not dissolved. Okay, and then you heat the filtrate in an evaporating dish until one of the third solution is obtained. Okay, and then you allow it to cool so that the salt will form. Okay, the one in the kurungan in the brackets you don't have to write. The moment you just write allow it to cool, you already get the next mark. Okay, the final mark. All right, so this one total of 7 marks. Just make sure that you write down the substance. You do not need to write down the variables the aim of the experiment, the hypothesis, the conclusion on it. When they talk about describe the steps, so the most you can write is what are you going to use. Okay, that would be one point. Then the next would be all for your steps. Okay, unless they mention to you, but of course in paper 2 they will not ask you on the hypothesis, the variable, more focusing on the procedure. Okay,